Welcome to the presentation for the Capture SDK for Flutter, provided by Socket Mobile. Let's get started. So first, Flutter is an open source framework by Google for building beautiful, natively compiled, multi-platform applications from a single code base. This makes development very seamless and easy. And it offers multi-platform support, including iOS, Android, and the web. It's a framework that leverages Dart, which is a programming language developed by Google that is designed to be fast and syntactically familiar. And I personally have to say that I really like how lightweight it is. Coming from someone who was a React and React Native developer, it's really nice not having to work with so many node modules and a bloated code base. So that much I like. The UI implements widgets for state management and rendering. These are akin to the components in React and React Native. So now onto the Capture SDK for Flutter. Basically, it allows Flutter developers to incorporate the Socket Mobile Capture library. It currently supports Android and iOS platforms. Web support is less of a priority at the moment because we have other web options, including the Capture.js web SDK, as well as the SDK for React. But there is a push in the future to enable that. To use Flutter in your application, you simply download the pub package and import it into your Dart files to be used in and along with your widgets. For this demonstration, I'll walk you through a Flutter application, go over how to import the package and how to initialize or open a root capture instance and connect to the capture library. Also introduce you to capture events as well as the different types of events, particularly device arrival, device removal, and decoded data. And you'll get introduced to capture properties as well as the methods used to retrieve and mutate those properties with get property and set property, respectively. And with that, let's jump right into the application. Okay, so here we are in our main Dart file in our sample app for the Flutter Capture SDK demo. As you can see up top, we have imported the Capture SDK package, which is live on pub.dev. You would install it like you would install any other Flutter package. There are a few things that you need to do before installing it so that you can get it, so that you can use it with iOS and Android. Those are covered in the README, so I won't get too into that right now for the sake of time. So let's just jump right into the code. So as you can see, we've imported the package here. So now we have access to all of the classes that are a part of this library. But before we get into that, I'll just talk about some of our state values that I've put in here for convenience. Status message. Status is basically letting you know what's going on with the application, what's going on with the library. We're making a request, we've received a response, stuff like that. This also will, show you any error messages that happen. And then message basically will just say like, oh, this was successful. This is the handle, whatever, updated this property for this device. Or it will be the error message should we get an error for any of our requests. Device list or devices. This is basically where we're going to store our connected devices, our scanners. New name is the state placeholder for basically, so in this app, the property that we're going to be working with is called friendly name. It's basically the string name that is assigned to a device. So basically, new name is going to be the what you type into the text box to update the device's name. And then here we have capture. This is essentially the first capture instance that we work with. It establishes the connection to the library. The next one is another capture instance called device capture. This is the instance that is tied to a device. It will allow us to basically access the device itself, its properties, and be able to use it to actually scan things. And then current scan, essentially, this is not super crucial, but right now I just use it so that you can see what a scanned data looks like. And this will all be visible in the UI. And then down here we have the name controller. This is basically just a text editing controller. It'll allow our text box to be controlled. Cool. So now that we've gotten that out of the way, I can move on to our logger. This is basically our logger instance that we've written to help us with stack tracing and basically print out more informative information regarding the various processes that are happening with the service. Our next function is update vals. This is just a helper function that I came up with to basically update the two values for our state, basically, status and message. So basically, it also includes, our method as well as our details. These are optional values because some of the responses will tell you what method the response is coming in from, as well as any details should it be, an error, should there be any further information that we need. So yeah, if there's a provided method, if there's an error, we just add that to the message. Same thing with details. And then, yeah, that's how we set the state. So now we update the values for status and message. And this is used throughout a few functions. So this is just a helper method for that. Okay, so now we move on to the init state for our widget. Basically, we initialize our name controller and we add the handle name change function. We add that to our name controller. So basically, anytime we update the text box, this function is going to get fired. And just quickly, this function basically just sets the state for new name. So yeah, there we go. Here we are. After that, we open capture. This is essentially the function that opens the first capture instance and then establishes the first connection with the capture service. So here what we do is we instantiate capture and basically we pass the logger to it so that now this logger is connected to this capture instance and we can start logging, all of the information that goes into it. And then we just store this in state because we will be using this later when we're working with our devices. So one of the parameters needed for open client, which is what is going to be used to establish that connection, we have to have app info that basically says that we are allowed to basically access the service. So here we have your Android app ID, as well as your Android app key, your iOS app ID, and your iOS app key. And then finally, we have the developer ID. So if you only want to use, if you're only developing for Android, you don't have to worry about this registration. If you're only, working on iOS, you don't have to worry about the Android registration. Sorry. But if you want to use both, it's two separate registrations that you have to do. And that's also covered in the README. So basically, once we finish instantiating our app information that's going to be passed to open client, we can essentially make that first request. We also pass a callback. I'll get to that in a moment. This is basically going to be how we handle various capture events. But yeah, like I said, I'll get to that in a minute. Here we have our status. So if it's successful, it's going to come back as an integer. So it'll say status handle equals the response, the message, capture open, successful. However, if there is an error, we wrap the errors in a capture exception. This is a way to like unify our error handling. And basically the exception that comes back, it's going to have a code, a message, and it will also have a method and details. The method is essentially the method where the capture exception occurred, and then details are just any further details pertaining to the capture exception itself. And then of course we pass all of that to update vals, and that updates our state values that will be reflected in the UI. So first, let's go to, here we have handle get name property, but I'll get to those after we talk about a few capture events. So here's the function that essentially listens to the various capture events that could happen. We also have another, logger execution just to kind of show, okay, on capture event from, and then these are the different event handles, or this is the capture handle. So here is kind of the important part. It's a switch that basically is driven by the event. This is going to be the event, that the capture event itself. It's driven by the ID of that event because there are different capture event IDs. I can actually just write this out really quick. Capture event IDs. And as you can see here, we have quite a few. Oh, sorry, wait, capture event IDs. Here we have battery level, buttons, etc. But the three that we're going to focus on right now are going to be a device arrival. This is essentially when a device is detected and is trying to connect to your application. Upon device arrival, we will instantiate another capture instance with our logger to help us with stack tracing. And device, we'll call it device capture because that's the state value that it's going to be stored in. And so basically, once we've done that, we can move on to open device helper. Basically, open device, as you see here, device arrival checks that the device is available. Open device allows the device to actually be used for decoded data, which essentially involves scanning. It allows us to update properties, access properties, etc. So in this function, what we're doing is we're basically, so we're basically setting a new value for our devices, our device list, accessing our logger again. And then here in, this is where we actually try to open the device. We get the device's GUI ID as well as the device name, which is just used for the logger itself. But the GUI ID is needed for open device. So for that, we pass the GUI ID as well as our root capture. And then if this is successful, it'll just return a 0 response because that's the response for no error. It'll basically add the value from the event, which is the device's data, to our devices list, and then we update the values accordingly. If there's any errors, it's caught in the catch part of this. So yeah, that's how we add a device and make sure that it is accessible. So let's actually go back down to our next one, which is device removal, which is pretty straightforward. It's essentially what gets executed once a device is removed from the service and it disconnects from your application. We have close device helper, which works similarly to open device helper, except it essentially closes the connection officially. If the response is good, it removes that device from our devices array and then resets all of our state values accordingly. Our next one that we'll go to is decoded data. This is the event that happens when your scanner actually scans something and picks up data. And we store that in current scan again so that you can just kind of see it, in the UI. And so yeah, and then it essentially just updates the value saying, successful scan, decoded data. Yeah. We have other ones that are for, S550 scanners for device manager. It's essentially similar to, device arrival and device removal, except the device manager basically can handle different devices as opposed to just a singular device on its own. Okay, so we're pretty much done with that. Oh, I almost forgot. So now that we've covered the different events, let's talk about our property handling. Okay, so here we have our handle get name property. This can be used with any of the properties. So actually, if you want to go, oh no, not that one. Let's do capture property IDs. Here you can see there are various capture properties that, or IDs that correspond to different properties for your devices. For demonstration purposes, I've decided to go with handle get name, which accesses the friendly name property for your device itself. That's basically just the string name. If you want to name your scanner, scanner 1, scanner 2, blue scanner, whatever. This is the property that you'll be updating and accessing. Although in this function, you won't be updating anything, you're just simply trying to retrieve the property. So what you do is you instantiate a capture property instance. You will pass the property ID. When you're getting a property, you'll pass the capture property type none. You'll also pass an empty, excuse me, an empty value argument. So here in our try catch, basically you're going to be using the device capture instance's get property method, and you will pass the property you've just constructed. If this is successful, you will get the property, and then the property response value will be the value for the property for the device. So basically it'll be this right now. If it's successful, will give you the name or the friendly name of that device that you have connected. If for whatever reason it fails, it's handled in the catch. Cool. So if you wanted to change the name, for instance, which I'll show you how to do in a little bit, essentially you'll use this function where you instantiate another capture property, except this time, instead of doing capture property types num, you will do string, because that's the data type for friendly name. And instead of an empty object, you'll be passing the actual provided string value that you want to update the name to. So if we go down here, we basically pass this property as an argument to the device's set property method. If it's successful, what ends up happening is the device's new name is now set to _ new name. If it's not successful, the error is handled accordingly. And then after that set property, just for convenience, I reset the state value for new name, and I clear the name controller to basically just start off, as empty as if it were you know, an empty text box. Okay, so there's essentially the basic rundown for the initial sample app, basically talking about how to import it into your Flutter application, how to establish a connection, how to handle various events, and how to get and set properties. So now I'll actually show you how it looks on the device itself. Okay, so this is basically what your app first looks like after you do Flutter run and then select if you have multiple devices connected. This is if you select your tablet or your iPhone. Um, this is what it looks like on an iOS device. Example would like to use Bluetooth. Okay. And then example would like to find and connected devices on your network. Okay. So this is an example of a device manager. This is from a previous connection. But for now, I'm going to be connecting a 740 handheld scanner. So I'm actually going to turn that on right now. I'm not sure if you heard the beep. But now it's just waiting to connect. There we go, and device opened, successfully added test new name. And as you can see, there's the new device underneath, test new name, with the GUI ID. So now, I don't really like that name, so, well first, I'll click the button next to get friendly name. Essentially makes a request, get property successfully retrieve the name, which we already got from the connection, but it's just to show you how the get request is a separate action or can be a separate action. So now let's do, instead of test new name, let's do my scanner. Keep it one word and then click the addition, successfully set name property to my scanner. Awesome. It didn't update in the device list just because I didn't feel like writing the code to do that right now. But if you were to connect it and reconnect it, then you would see the change reflected. But I won't do that right now. Instead, I'm going to pull up a QR code on my laptop, QR code, and I'm going to scan it so that you get a little bit of insight on what a QR code scanning looks like. Remember, in our code, we had that current scan state property value. That's what's getting updated right now. So I'm going to scan a QR code that I found. So there you go, decoded data, successful scan. And then at the bottom, you can see scan data scanned from QR code. And then that's basically just an int array. But here, let's do another one. We'll do barcode. So it looks a little different if it wants to scan it. There we go. Scan from GS1. So these are basically just examples of different things that can be scanned. Here I'll do another one. Scan from UPCA. Scan from code 39. So basically what's happening now is I'm scanning a bunch of different barcodes on my computer. Yeah, all right, so now I'm gonna turn the device off and you'll see it, device closed, successfully removed, test new name, and I removed it from the device list. So that's a pretty basic, rundown of some of the things that you can do with a scanner in a Flutter application. And yeah, this was my first tutorial, so hopefully, I know it was kind of long, but hopefully it was insightful. So yeah, take care.